This video is going to cover simplifying trig expressions using some fundamental identities. Please feel free to pause it at any time so that you can write stuff down or copy or whatever you need to do, okay? Some of this is going to go kind of fast, so it's not a really long video. First, I like to keep a sheet like this, and I recommend you do the same, that has all of the identities and rules that we use on one side and then what I call our toolbox on the other. So first, let's think about what identities and rules we have right now. We have the reciprocal identity, the quotient identity, and our Pythagorean identities. And those three are the ones we're going to use the most often. We also have even odd, which we only use when we have a negative theta. It's really obvious when we use that. We have cofunction identities, which we only use when we have a 90 minus theta. And so what we're going to do through this video is we might come up with a couple of other rules, and we're going to work with what we might put in our toolbox. So first, we're going to work on simplifying this trig expression. When we simplify expressions, we're just trying to make it as simple as possible. And they're not going to ask us to give a reason for our steps or how we get there. But in preparation for proving identities, we're going to go ahead and do that in this video. So for this problem, in order to simplify it, what we would do is turn everything into sine and cosine. So I would turn that cotangent into cosine over sine, and my reason, or what allows me to do that, is the quotient identity. And then my sines would cancel out, right? So then I would be left with a cosine. And my reason for that, when you look at that, you say, well, duh, because it cancels out, it's math, right? And anytime that's kind of your reason, that reason is algebra. So let's go back to our original sheet and add the things we just came up with. First, we're going to add the rule of algebra over there. So it's not an identity, but it is a rule, and it's one we're going to use a lot when we prove identities. And then in our toolbox, let's add change to sine and cosine. Okay? Here I have tangent over secant. I know I'm going to have to turn everything into sine and cosine to make that simpler, but before I do that, I'm going to rewrite that as horizontal division. A lot of times when we end up with a fraction over a fraction, it causes some confusion for students. So if we can rewrite that as horizontal division, it makes things a little bit easier sometimes. And our reason for that is algebra. Next, I'm going to turn tangent into sine over cosine. And my reason, or the identity that allows me to do that, is the quotient identity. And then I'll turn secant into 1 over cosine using the reciprocal identity. So now I have that horizontal division. So when I divide fractions, I do keep, switch, flip, right? Keep the first one, switch your sign to multiplication, flip the second one, and that's by algebra. Then I'm going to have those cosines cancel out, right? And I'm left with sine by algebra. So now we're going to go back to our sheet here, and we're going to add our new tool, which is rewrite as horizontal division. Now we have sine squared minus sine squared cosine squared. The first thing I think of when I see this is that I must have some Pythagorean identities in here. So I'm going to keep Pythagorean in my head. But first I see that I have sine squareds that I can factor out. So I can factor that sine squared out, and my reason for that is algebra, right? And then that 1 minus cosine squared is part of a Pythagorean identity. If you need a little refresher, there it is. That sine squared is 1 minus cosine squared. So I can make that replacement. And the reason I can do that, or the identity that allows it, is the Pythagorean identity. And then I'm left with sine to the fourth, which is just algebra. So now let's go back to our sheet here. And I'm going to go ahead and add Pythagorean to my toolbox. Even though it's an identity or a rule as well, it's also a tool that helps us make things simpler. And we're also going to add factor because we'll end up factoring quite a bit. Okay, last one here. I don't have any squared, so I'm not going to be looking at a Pythagorean. I don't have a reason to factor anything, so I'm going to need to turn everything into sine and cosine. But first, we'll go ahead and rewrite it as horizontal division, and my reason for that is algebra. Then I'll turn that secant into 1 over cosine, and that reason is the reciprocal identity. Next, I'll turn the tangent into sine over cosine by the quotient identity. Next is keep switch flip, right, when I divide fractions by algebra. Then everything cancels out, and I'm left with a 1 by algebra. All right, hopefully you're ready to give it a try yourself.